This is Mohammad Mahmoudi Zarandi, and this is the second project for Medical Robotics and Systems course at Wayne State University. The second project is an extension of the first project in the way that we are able to connect the Arduino hardware to the GUI and load and actually browse through MRI slices in the GUI, which I'm gonna show you in the next couple of minutes. For now, I like to go through the whole actually GUI and see how does the program works. For the first project, we provide a DH input table here, which enables the user to actually input the GUI, the DH parameters, and simulate the robot here to the maximum of 6 degrees of freedom. Here I'm gonna create a 3 degree of freedom just to show how does the robot work. So we have to input the parameters in here. I'm just gonna enter some random just to check, just to show actually that the robot works. After entering the DH parameters and pushing the simulate, it will simulate the robot here for us. Sorry for that. And we provided some sliders that enable us to move the robot arms like this. And this robot is actually 3 degrees of freedom. For the second project, these sliders actually they do the forward kinematics, and for the second project we provide these push buttons for the which does actually the inverse kinematics. And since inverse kinematics goes through some iterations to get the answer, it takes kind of time, and it might be somehow glitchy when the robot arms want to move, and you can see it when I move it here. And as you see, it works now. I can move the end effector in X axis, Y axis, and Z axis. As you see. Okay, and here I'm able to connect the Arduino. Arduino is connected here. As you can see, we have 3 LEDs in here. When the Arduino is connected and the axial is selected here, the axial LED would be turned on. If I select the sagittal LED would be turned on, and so on, control. And here I'm able to, the depths actually enabled me to browse through the pictures, because after I load the MRI pictures I would have 27 axial slices, 35 sagittal slices, and 45 coronal slices. And if this depth is chosen, I can browse through those slices through these potentiometers, through this analog read. And also, if I choose the contrast here and move this potentiometer, gives the different values to the Arduino, it would change the contrast of that picture for me. And also in here I'm able to change the brightness. Okay, now I'm gonna connect the Arduino. So as you see, it's trying to connect here. Now I've in here I have axial slices selected with depths. Now I'm gonna move this potentiometer. I should be able to see different slices browsed here. No, completely works. Now I can choose contrast. As you can see, I'm able to change the contrast and also the brightness. And for sagittal, after I choose sagittal, the axial LED turns off and sagittal LED turn on here. Now I should be able to browse through the slices, changing the contrast. And changing the brightness. Also for chronal, through changing the potentiometer value, it's giving me the different slices. I can change the contrast. And the brightness. Okay. Here we are with the select region, we are able to digitize, actually to select the regions of interest and make slices of that region of interest in this plot. And through the Dillonite triangulation, we would create a 3D model of those slices that has been selected in this plot in here. So I'm gonna select and I'm gonna select different regions in this picture. Press enter. Okay, this is the first. After I change the picture, select another region, change again, select another region, after you can see different slices, and pushing the create 3D model, it would actually create this model. And also this robot was designed to be able to draw the reach envelope, which for the end I would put it to drive the reach envelope as well. And here was the second project. Thank you so much.